Our bodies are incredibly complex machines, constantly working to keep us alive and functioning. Even when we're resting, our cells are hard at work, repairing damage, fighting off invaders, and keeping things running smoothly. But what happens when these processes become less efficient? What if there was a way to enhance our body's natural ability to heal and protect itself? Enter autophagy and intermittent fasting. Autophagy, a natural process of cellular renewal, acts as our body's internal recycling system, breaking down and removing damaged components. Intermittent fasting, a pattern of cycling between periods of eating and fasting, has emerged as a powerful tool to activate this process. Together, autophagy and intermittent fasting offer a powerful strategy for improving our health and potentially extending our lifespan. In this exploration, we'll delve into the fascinating world of autophagy, understand how it works, and explore the benefits of incorporating intermittent fasting into our lives. By understanding these processes, we can unlock our body's innate ability to heal, regenerate, and thrive. Let's begin our journey into the world of autophagy and discover the transformative power it holds. Imagine your cells as bustling cities, with organelles working as factories, power plants, and recycling centers. Just like any city, cellular processes generate waste. Autophagy is the waste management system of the cell, ensuring that damaged components are efficiently removed and recycled. The term autophagy originates from the Greek words auto, self, and phagein, to eat, literally meaning self-eating. While this might sound alarming, it's a crucial process for cellular health and longevity. Instead of literal self-destruction, autophagy is a highly regulated and beneficial process of cellular self-renewal. The discovery of autophagy can be traced back to the 1960s. However, it was the groundbreaking work of Japanese cell biologist Yoshinori Ohsumi in the 1990s that illuminated the intricacies of this process, earning him the Nobel Prize in Physiology or Medicine in 2016. His research, conducted on yeast cells, revealed the key genes and molecular mechanisms driving autophagy, providing a foundation for understanding its significance in human health. The process of autophagy, while seemingly complex, can be broken down into a series of manageable steps. Think of it as a well-coordinated cellular ballet, with each step playing a crucial role in the overall performance. First, the cell identifies damaged or dysfunctional components such as misfolded proteins or worn-out organelles. These targeted components are then engulfed by a double-membraned vesicle called an autophagosome. The autophagosome acts like a cellular garbage bag, encapsulating the targeted material. Next, the autophagosome fuses with a lysosome, another cellular structure containing powerful digestive enzymes. This fusion creates an autolysosome, where the engulfed material is broken down into its basic building blocks. These recycled components are then released back into the cell, providing valuable materials for energy production or the synthesis of new molecules. This elegant process of cellular recycling ensures that our cells remain healthy and functional. By removing damaged components and recycling valuable resources, autophagy contributes to cellular rejuvenation and overall well-being. While autophagy occurs at a basal level in our cells, certain conditions, like nutrient deprivation, can significantly upregulate this process. This is where intermittent fasting comes into play. Intermittent fasting, a dietary pattern characterized by cycling between periods of eating and fasting, has gained significant attention for its potential health benefits, including its ability to stimulate autophagy. When we fast, our bodies undergo a series of metabolic shifts. As glucose levels decline, the body turns to stored fat for energy. This metabolic switch triggers a cascade of signaling pathways that activate autophagy. One key player in this process is a protein called mTOR, or mammalian target of rapamycin. mTOR acts as a cellular nutrient sensor. When nutrient levels are high, mTOR is active, promoting cell growth and inhibiting autophagy. However, during fasting, mTOR activity decreases, lifting the brakes on autophagy and allowing this cellular cleansing process to accelerate. By incorporating intermittent fasting into our lifestyle, we can harness the power of this natural process to enhance cellular renewal and promote overall health. Autophagy extends beyond cellular housekeeping, playing a crucial role in health and disease prevention. It enhances cell repair, removes damaged components, and promotes rejuvenation. This process helps prevent age-related diseases by reducing cellular dysfunction. Autophagy also plays a role in preventing cancer, Alzheimer's, and heart disease. By removing damaged components, it supports cellular function and reduces disease risk. The benefits of autophagy are not merely theoretical. Numerous studies have demonstrated its real-world impact on health and disease. For example, research on mice has shown that fasting-induced autophagy can extend lifespan and improve metabolic health. In one study, mice fed a calorie-restricted diet, known to induce autophagy, lived significantly longer and had a lower incidence of age-related diseases compared to mice fed a standard diet. These findings highlight the potential of autophagy to promote longevity and improve overall health span. Human studies have also provided compelling evidence for the benefits of autophagy. Research on intermittent fasting, a potent inducer of autophagy, has demonstrated its efficacy in improving insulin sensitivity, reducing inflammation, and promoting weight loss. Moreover, studies have shown that intermittent fasting can improve cognitive function, reduce the risk of heart disease, and even enhance the effectiveness of certain cancer treatments. These findings underscore the translational potential of autophagy-inducing interventions for improving human health. The discovery of autophagy has revolutionized our understanding of cellular health and longevity. This elegant process of cellular self-renewal plays a crucial role in maintaining our well-being and protecting us from disease. By incorporating intermittent fasting into our lifestyle, we can harness the power of autophagy to enhance our body's natural healing abilities. While more research is needed to fully elucidate the intricacies of autophagy and its implications for human health, the evidence to date is incredibly promising. Intermittent fasting, a safe and accessible dietary intervention, provides a practical way to tap into the power of autophagy and promote optimal health. As we continue to unravel the mysteries of autophagy, we can expect to see even more innovative strategies for harnessing its power to prevent and treat disease. By embracing the power of autophagy, we can unlock our body's innate ability to heal, regenerate, and thrive, paving the way for a healthier and more vibrant future.